So welcome again. This is a small, quick update. This is just right after recording the last video for the G400. I want to show what I finally managed to achieve. It took me so much time, but I got there. So you might be familiar with the control unit I'm building for the next processor. Last time I did not have hooked up the programmer, and I recognized after a lot of hours of work that I was missing some cables. And since I don't have red, I used what I had and I made it work, and it's working finally. I'm happy for it. So what I have here in my computer is the program to manage everything. A12, which is the 13th bit for the EEPROMs. It's controlled by the microcontroller itself. Since I don't have it hooked up to no instruction register nor a flag register, which is the purpose of that address line. So I wrote some code to upload instructions. Uploading an instruction, what it does is it sends the value through the shift register. The other code I'm using here is the program serial, which does the same but for the programmer. So I send 24 bits through those three shift registers. This is just to handle collisions between write enable and output enable. I don't want them on at the same time. So right now with the green LED, we know we're in run. So what are we seeing? Nothing, because I loaded 0 and that address, and I'm so happy I was able to load something, to finally write something into the EEPROM after so long. So here I wrote the write tick. It should take about 2.5 milliseconds to write a byte. However, I noticed some inconsistencies and I decided, okay, let's do it 7 milliseconds. I'm not in a hurry. I also made the set address, which is way much more beautiful than the kind of code I had for the G400. It clears when it says program.clear. I'm referring to the instruction upload part. Why I named it program, not sure, but anyways, it clears the instruction register. That includes the instruction counter, and I say it because I had a separate function for that, and I'm quite happy I don't have it anymore. Also clears the shift registers, so every register in that board clears when you use that instruction. So when I'm setting an address, I'm gonna clear the registers. I'm going to print the address I want. Then I'm gonna set the 12. Well, I'm gonna set A12 depending if the hex value is more or equal than 0x1000 or 0x1000. Otherwise, if it's less than 0x1000, the A12 is low. The middle part is the next 8 bits, which are directly wired to the instruction register. So those 8 bits come through here, through the serial, the shift register comes through here, and then load into those 2 4-bit registers, which make the 8-bit register. And then you'll see that at the bottom it uses a different routine because I don't have a way to directly write to that register. Since I'm using it as a counter, all I do is, depending on the value of that last nibble, I'll count to that value, and then I get my full address. So a write uses the set address function. So it sets the address or the instruction, and then in the control write, what it does, it loads 24 bits to these 3 registers and a write tick. So if I were to do that, let's do a write to address 0, let's do a 10 just cause should load 10. Let's see if that's true. Yeah, it did. I don't know if you're able to see that. The light I'm using to illuminate this might be way too bright. Let me turn it off for a second. There you go. So another thing I wrote was a fill. Just give it a value. Let's say FF. Should fill the EEPROM with that value. So let's set the address to 0. Yep, it's all FF. Okay, what else do I have? I have a comb instruction, function. This is to make sure that it actually wrote what I wanted it to write, and you can see it did not. I've been encountering this problem for a few hours now. What I will do whenever I'm going to program the EEPROMs is run the program cycle multiple times to make sure it loaded the right values. That's not the most elegant solution, but since I don't have a way to actually read what the EEPROM is outputting, I'm just gonna have to suffice with that for the time being. I might actually use in the future a parallel to serial shift register, but I'm not sure about that. Maybe. And the last function, dpro, which is deprogram, it follows the routine to deprogram the write protection out of the EEPROMs. And you might be able to see that one of the EEPROMs doesn't have the sticker I put on it because I had to switch it. The other EEPROM didn't want to come out of that write protection state, so I just replaced it and ran the write protection disabling code on that one. So this is pretty much the update for the control unit.